So we've already talked about monomials and how they are a term in an expression or an equation, just one single unit. So a polynomial is an expression consisting of many terms. So that poly root or prefix again means many. So it's an expression consisting of those many terms. So for example, something like 4x squared minus 1 is a polynomial. 9x cubed plus 4x squared minus x minus 2 is also a polynomial, anything like that. Now, polynomials can also include, it's kind of a larger umbrella, so they can also include those monomials like 5 or 2x squared as well. Those are also considered under the polynomial umbrella, even though they have only one term. So standard form is the way that we write polynomials in the most, it's the way that we write them across the board. Everybody will write them the same way. It's just kind of a standard procedure that we use for writing them. And so it must be written in alphabetical order with the highest exponent coming first, the highest exponent of that alphabetical order, and then we work our way down from there. Okay, so for example, a standard form for a polynomial here, we want to go with, we notice that there's one variable here, so we're going to start with the x, and we're going to go with the highest exponent. So we have a 2, a 1, and then we have one without a variable, or it's an exponent of 0 on that variable. So we're going to start with the highest first, so we're going to write it as 2x squared, then go to the next one, plus 3x plus 1. So that's going to be our standard form. Similar situation, we can look at example number, let's look at 5. So on 5 here, it's a little bit different because now we have multiple variables. So we're going to start with alphabetical order, which is a. So we're going to start with the a, and we're going to start with the highest exponent of a, so a cubed. Then I'm going to go to the next highest exponent of a, which is a squared. So, sorry, let me rewrite that. A cubed plus 5a squared b squared. So we're going to use this term next because it has the next highest exponent of a. Then we're going to go to this term because it has the next highest exponent of a, so plus 2ab. And then finally over here, there's not an exponent for a, so we move on to the next variable, which would be b, so negative 2b cubed. Okay, even though we've got a b squared over here before this one, it's okay because our standard form always takes care of that first alphabetical letter and works its way all the way down before we move to the next letter in the alphabet. Okay, so just keep that in mind as we work through some of these. So you've got a few more examples there that you can check for your understanding and make sure that you're okay on that. Okay, all right, so then we're going to talk about degree. A degree is the highest exponent of a polynomial. That's a degree. And so we classify polynomials in two different ways. We classify them by the highest exponent, degree, and we also classify by how many terms they have. And so we kind of give them a specific name based on that. So if the highest degree is 0, meaning there's no variable, it's a constant, and we know that. A number we know as being a constant from our vocabulary from the beginning of the year. If there is 1, or the exponent, highest exponent is 1, it's a linear. If it's 2, it's quadratic. If it's 3, it's cubic, and if it's 4, it's quartic. And those are the ones that you should know at this point. Now, number of terms is how many pieces or how many terms are we adding or subtracting together in that polynomial. So if there's only 1, we know that to be a monomial. That's what we dealt with last week as we were going through these. 2 terms is called a binomial. That bi prefix meaning 2. Trinomial is 3, and then of course anything else we just refer to as a polynomial, meaning many terms. But like I said, polynomial is kind of the big umbrella. We use it to describe any of them, but if we want to get more specific and name them technically, we use monomial, binomial, and trinomial for the first 3 terms before we switch to calling them polynomials. So just a couple of examples here. So like looking at number 7 here. So number 7, you notice that there is no degree. The highest degree is 0 because it's really x to the 0 power, which is 1. 1 times 6 is still 6. So there's no variable, no exponent here. So this is a constant. And there's only one term here, so we're going to call this a monomial. If you look here at number 11, for example, here we have a degree of 3. It's the highest exponent that we have is a 3. So we're going to call this a cubic. And there are 2 terms, 2 pieces that are being added or subtracted together. So we're going to call that a binomial. Okay, and then we can also do like number 10 here, where we have an exponent of 0, of 1, and of 2. The highest is 2, so we're going to call that quadratic. And then there are 1, 2, 3 terms, so we're going to call that a trinomial. Okay, and so again, there's just a few more problems there that you can check your understanding and make sure you're on the right track. Now, I do want to talk a little bit today as well about adding and subtracting polynomials, which we've already discussed. It's the same as adding and subtracting monomials, except for now there's just more pieces that we're going to be adding and subtracting together. So the important part to remember about this is combining like terms. When we add or subtract polynomials, just like with monomials, we're just combining like terms. That means that the variables and the exponents have to match in order for us to combine them, and we're only combining the coefficient. So it's very important that you remember that. We don't change anything with the exponents, with the variables, we're only changing the coefficient, okay? So when we look at addition here, I'm going to be adding here this x squared and this x squared because they both have the same variable and exponent. And then all we're doing is combining the coefficient. So -1 and +2, -1 plus +2 is going to become a +1. Then we have this x here and an x here, so these have the same variable, just x with an exponent of 1. And we have 11 plus -5, which is a +6x. And then we have this 13 and this -23 that we need to combine because they are both constants and there's no variable with them. So 13 plus -23 becomes a -10. Okay, and notice I went ahead and just started with the highest exponent and worked my way down so that my answers would already be in standard form. But if you didn't, if you started here with 11x and went from there, you would just need to rearrange this into standard form. Okay, all right, subtraction here. So again, now we're going to be subtracting, so we're going to pay close attention to this. Again, I'm going to start with my highest exponent. So here I have an x squared and here I have an x squared. Because they have the same variable and exponent, I'm going to go ahead and subtract their coefficient. So 4 minus 3 becomes 1 x squared. Notice that I'm not changing the exponent and the variable. I didn't over here either. When I added these two together, I only added the coefficient. I left the exponent and the variable alone. Then I have this 5x and this 7x. So 5x minus 7x becomes -2x. And then what you got to be careful about here is that here we have a 0 as far as a constant goes, but here we have a 1. So it's 0 minus 1 gives us a -1 here. So don't get tripped up on that. You got to remember that it is a negative there. Okay. So let's just talk through a couple of these examples, and then I'll give you an opportunity to check your understanding on that as well. All right. So let's look at let's say number 15. That's a good one to start with. So notice on number 15 we do have cubed here, so and a square and then a 0 exponent. So I'm going to start with a cube. There's nothing to add it to, so I'm going to bring it down. There's a squared and a square here. They both have the same variable and exponent, so I'm going to add these together. -2 and 3 becomes +1. And then finally we have a -5, this constant, and this constant right here. -5 plus -11 is -16. And because I'm doing these in the greatest to least order of exponents, I've already got them in standard form. Okay, let's look at another example where, let's see, we have, let's do example number with 20 because we have 2 different variables here. So first off, you notice that combining like terms, we have to have the same variable. So 5r and 9r. This time we're subtracting. So 5r minus 9r becomes negative 4r. Then we have a negative 2s and a negative 11s, and it's negative 2 minus a negative 11, negative 2 minus a negative 11. So this becomes a positive negative 2 plus 11, which is negative, which is a positive 9s. And again, QRS in order of alphabet, it's already in alphabetical order, so we can leave our answer just like that. Let's see. Let's do one more example. We'll look here at number 23. So here again, I'm going to start at the beginning with my highest exponent. So I'm going to use that negative v squared and this positive v squared. And I am subtracting, so it's negative 1 minus 1, which becomes negative 2v squared. Then I have a 7v and an 8v, and I'm subtracting 7 minus 8, so I have a negative v. And then finally 14 minus 15, which is also a minus 1. So we end up with negative 2v squared minus v minus 1. Okay, so just be very careful as you work through these. It might be helpful for you if you wanted to use 3 different colors of pen or highlighter or something along those lines. You could do that just to kind of color code things. Like, so for example, like on number 22, I could use a blue to kind of underline the ones that have squares. I could use green to underline the ones that don't, and then I can use my pink for my constants here. And that kind of color codes my my combining like terms, my like terms, so that way I know that those two go together, these two go together, and then finally the pink goes together. It makes it a little bit easier to see so that it's not all the same color. So that might be something that's helpful as well. But you've got several problems here. Check your understanding. Make sure you don't have any questions. If you do, please ask them. Make sure that you know how to complete these. We're going to add in multiplication tomorrow.